Light is the universe's speedster, moving through a vacuum at about 300,000 kilometers per second, but it can be slowed to a crawl, even brought to a complete stop in a laboratory. When light passes through certain ultra-cold states of matter, like a Bose-Einstein condensate, a cloud of atoms chilled to near absolute zero, it interacts so strongly that its speed can be reduced to just a few meters per second, slower than a bicycle. Scientists have even stored light by transferring its information into the spin of atoms, then releasing it again later. This shows that the speed of light is not an inviolable constant in all circumstances, but a speed limit for empty space. When light enters the realm of matter, it can dance to a different, much slower rhythm, revealing the profound interplay between energy and the strange states of matter at the quantum edge. Languages connect communities, often spoken by millions. But imagine being the last living soul to speak your native tongue. This is the reality for languages like Busuu, named for a language in Cameroon that, at one point, was reported to have only 8 speakers. Around the world, there are languages held by a single elder. That person becomes a living library, carrying within them unique ways of seeing the world, histories, jokes, and wisdom that exist nowhere else. When they pass, an entire cultural universe, centuries of thought and tradition, goes silent forever. This stark reality highlights language not just as a tool for communication, but as a unique ecosystem of the mind. It compels us to listen to the most fragile voices, for they hold irreplaceable pieces of human imagination. We might think of collecting beautiful stones or shells, but imagine an animal that builds structures so vast they are visible from space. In the arid landscapes of Australia, a small, quiet bird called the great bowerbird spends its days gathering bones and shells. Yet its true masterpiece is not what it collects, but the stage it creates. The male bird meticulously arranges these items, preferring white, gray, and, most curiously, vivid blue objects like bottle caps and plastic pieces in a courtyard to attract a mate. He positions them so perfectly that they create an optical illusion, making his display look larger and more impressive to a watching female. This reveals that the drive to create art and architecture isn't unique to humans. It's woven into the fabric of other minds. It's a humbling reminder of the profound creativity hidden in the quiet corners of the natural world. In the heart of the Saharan Desert, one of the most barren places on Earth, lies a treasure that defies all expectations: the world's largest supply of fresh water. This isn't a river or a lake, but a vast hidden reservoir known as the Nubian Sandstone Aquifer. Locked deep beneath the sand and rock for thousands of years, it holds an estimated 150,000 cubic kilometers of water. That's enough to cover the entire landmass of Germany to a depth of nearly 1 kilometer. This water fell as rain in a different age, when the Sahara was a green savanna, and has been preserved in a natural underground library, page by page, over millennia. It teaches us that what we see on the surface is only a fraction of the story. The Earth has deep, hidden histories stored in its very bones, and the most precious resources are often kept in the least likely places. We imagine the greatest mountain ranges carving across continents, visible for miles. But the largest mountain range on Earth is completely hidden from our sight. It lies not on land, but coiled around the planet deep beneath the ocean's surface. This is the mid-ocean ridge, a continuous chain of volcanoes and valleys that winds through every ocean for over 65,000 kilometers. If placed on land, it would dwarf the Himalayas in both length and volume. Here, the planet's tectonic plates are slowly pulling apart, creating new ocean floor from molten rock and heating the deep, dark water to support entire ecosystems of strange life. This hidden backbone of our planet reminds us that the most significant features of our world are often unseen, shaping everything from the chemistry of our oceans to the very continents above in a slow, powerful dance of creation. We think of armies as groups of individuals, but what if an army was actually one single ancient being? In the mountains of Utah, there is a grove of quaking aspen trees named Pando. From above, it looks like a vast forest of 47,000 individual trees, but scientists discovered that every single trunk in this 100-acre expanse is connected by a single, gigantic root system. They are all genetically identical shoots, or stems, rising from one of the largest and oldest living organisms on Earth. Pando is estimated to weigh nearly 6 million kilograms and is thought to be over 80,000 years old. It was already ancient when the first humans reached North America. This changes our definition of an individual. It is a reminder that life can find profound resilience in unity, and that the oldest stories are often growing quietly right beneath our feet, waiting to be understood not as a crowd, but as one. History is filled with tales of impossible celestial events, but what if one of them was verified by science? Over 3,200 years ago, according to an ancient text, a leader prayed for the sun to stop in the sky to win a crucial battle. For centuries, this was considered pure myth. Then, modern astrophysicists ran the numbers on Earth's rotation, modeling its changes over millennia. They discovered a remarkable fact. On a specific date in 1207 BCE, a solar eclipse occurred over the ancient region of Canaan, and more importantly, the Earth's rotation had not experienced one of its periodic tiny slowdowns yet. The combination of these events meant that, relative to the local perception of time from sundials, a full day of sunlight appeared to be granted. The prayer wasn't for a stop sun, but for more daylight, and the cosmic clockwork, by pure chance, made it seem so. This shows how ancient stories can be windows into real historical moments seen through the lens of the knowledge of the time. It connects human drama directly to the immutable motions of the heavens. Sharks have been swimming in Earth's oceans for over 400 million years. The first trees didn't appear until about 350 million years ago. That means sharks existed for roughly 50 million years before forests even covered the land. When the earliest sharks were evolving, the continents looked completely different, and nothing taller than small plants grew on land. These ancient sharks looked different from modern ones, but they already had the core features: cartilage skeletons, multiple rows of teeth, and streamlined bodies built for predation. They survived the mass extinction that killed the dinosaurs. They survived ice ages, volcanic eruptions, and asteroid impacts. While countless species rose and fell, sharks endured, adapting slowly but successfully to every change the planet threw at them. They are older than Saturn's rings, older than the Rocky Mountains, older than almost anything we can see around us. Their longevity isn't about strength or size. It's about adaptation and resilience. Sharks remind us that survival across deep time requires not perfection, but flexibility, and that the oldest designs are often the ones that work well enough to never need replacing. We all know that animals need to eat food to survive, but deep in the ocean, there is a creature that seems to break this fundamental rule. It's a sea slug called the Eastern Emerald Elysia, a beautiful, leaf-shaped animal that grazes on algae. But it doesn't just eat the algae, it performs a kind of gentle theft. The slug carefully extracts the tiny solar-powered factories from the algae's cells, the chloroplasts, and incorporates them into its own body. Once stolen, these green machines continue to function, turning sunlight directly into energy for the slug. This means that for months at a time, this animal can essentially survive by sunbathing, becoming the only known animal that can truly photosynthesize like a plant. It blurs the very line between animal and plant, showing us that the rules of biology are not always rigid, but can be bent through astonishing acts of natural collaboration. We build bridges with steel and concrete, but in the rainforests, engineers work with silk. When small gaps open in the forest canopy, social spiders perform a feat of collective engineering that seems straight out of a myth. A pioneer spider will release a strand of silk that catches the wind, a process called bridging or ballooning. When this gossamer thread snags on a far branch, the spider reinforces it. Then hundreds or thousands of its fellow spiders follow, adding their own silk to create a dense, living rope bridge strong enough for them to cross en masse. They build a new communal web on the other side. This shows that cooperation can achieve literal bridges where no single individual could possibly succeed. A lesson in unity written in the strongest material, pound for pound, found in nature. Look at a rainbow, and you'll see a spread of beautiful colors. But there is one color you have never seen and never will. It's called impossible red, or more technically, a reddish green. Our eyes perceive color through opposing channels, red versus green, blue versus yellow. These are opponent colors, and our neural wiring makes it physically impossible to see a color that is both truly red and truly green at the same time. They cancel each other out. You can see yellowish red, orange, or bluish red, purple. But a pure spectral red-green is a blank spot in our perception of the universe. This reveals that the vibrant world we experience is not an absolute reality, but a carefully constructed model built by our brains. There are shades of light that exist, but for which we have no visual concept, locked outside the gallery of our minds. We think of fish as creatures bound to the flow of the river. But in the steep streams of Hawaii, there is a small goby that performs a feat that seems to defy its very nature. It climbs towering waterfalls. The nopally rock-climbing goby doesn't use fins to scale these sheer, wet cliffs. Instead, it has evolved a remarkable suction cup, formed from fused pelvic fins, on its underside. Using this biological suction disc and a powerful muscular mouth that acts like a second suction cup, it inches its way upward in a series of deliberate, straining pulls. It climbs hundreds of feet to reach the calm pools at the top of isolated volcanic valleys, completing a life cycle that is a testament to sheer tenacity. This journey reminds us that evolution can shape life into forms that conquer seemingly impossible barriers, all for the simple, powerful drive to find a home. When Mount Vesuvius erupted in 79 AD and buried the city of Herculaneum under volcanic ash, it destroyed almost everything. But it also accidentally created the only intact library to survive from the ancient Roman world. The intense heat didn't burn the papyrus scrolls stored in the Villa of the Papyri. Instead, it carbonized them, turning them into fragile black cylinders that look more like charcoal than paper. For centuries, no one could read them without destroying them. But recently, scientists using advanced X-ray technology and artificial intelligence have begun reading the text without ever unrolling the scrolls. They're discovering lost works of philosophy, poetry, and knowledge that no one has read in 2,000 years. The same disaster that silenced these voices also preserved them. What seemed like total destruction was also perfect preservation. It teaches us that catastrophe and salvation can be two sides of the same moment, and that some of humanity's greatest treasures survive not despite tragedy, but because of it, waiting patiently in the dark for the right moment to speak again. It sounds unbelievable that an animal could survive with three hearts. We grow up thinking one heart is the absolute rule of biology. Yet octopuses quietly break that rule beneath the ocean. Two of their hearts pump blood to the gills, while the third pumps it to the rest of the body. The strange detail is that when an octopus swims, the main heart actually stops beating, which is why octopuses prefer crawling over swimming. This setup exists because their blue copper-based blood needs extra circulation to carry oxygen efficiently. The lesson is that evolution doesn't aim for simplicity, it aims for what works. Nature often solves problems in ways that feel alien, yet perfectly logical once understood. It sounds wrong to think mountains could grow taller. Mountains feel ancient and worn down by time, but in some regions, tectonic plates are still pushing together, slowly lifting mountain ranges higher each year. The strange truth is that while erosion wears mountains down, Earth's internal forces can raise them back up at the same time. This balance happens over millions of years, far too slowly for us to notice. The realization is that Earth is still actively shaping itself. The lesson is that what looks finished may still be in progress. Even the oldest landscapes are part of an ongoing story. We know ice is frozen water, cold and inert. But at the bottom of the ocean, under immense pressure, there exists a form of ice that you can literally set on fire. It's called methane clathrate, or fire ice. It's a crystalline cage of water molecules that traps highly flammable methane gas inside. In the deep sea's cold and pressure, it stays solid. But bring a chunk to the surface, and as it melts and depressurizes, it releases pure methane gas that can be ignited with a match, creating the surreal spectacle of burning ice. These underwater deposits hold more carbon than all the world's known fossil fuels combined. This strange substance is a powerful reminder that the familiar elements of our world can combine under extreme conditions to create wonders that defy our simplest categories, holding both great energy and great consequence. It feels impossible that a massive iron monument could change its height. The Eiffel Tower looks solid, rigid, and permanent. But during hot summer days, the metal expands, causing the tower to grow about 15 centimeters taller. The surprising detail is that the structure isn't stretching upward intentionally, it's simply responding to basic physics. Iron expands when heated and contracts when cooled. This happens so gradually that visitors never notice it happening. The insight is that even our strongest structures are quietly moving and adapting to their environment. Nothing we build is truly frozen in place. The world is always in motion, even when it appears still. Before modern tools, humans navigated vast oceans using only the stars, the sun, and their own minds. But the most precise tool they used was not a device, but a part of their own body, their hand. Polynesian voyagers, master navigators of the Pacific, used a technique called star pathing. They would hold their hand at arm's length, using the width of a finger, a fist, or a span between specific fingers to measure the exact angle of a star above the horizon. This created a celestial calculator, allowing them to determine their latitude with astonishing accuracy, guiding their canoes across thousands of miles of open ocean to pinpoint islands. This reminds us that the most advanced technology is sometimes the knowledge embedded in our own physiology and perception, a deep conversation between the human body and the cosmos.